Hello everyone. The title of this video is section 4.1, Solve a system of linear equations using the elimination method. Alright, so in this video I'm going to be taking you through a version of the Knewton Alta assignment for section 4.1. Please be aware that the questions that I see in this video aren't necessarily going to be the same questions exactly, that you're going to see when you work on the assignment yourself. But I'm hoping that this will help when you do work on it on your own, because the objectives will be the same and the way I would work on the problems would be the same as well. Alright, so here's the assignment page. You're not going to see the word preview, right? You'll just see the title, the mastery bar, the objectives. Now there are two objectives, one under this heading and one under this heading here. And then the questions, and the feedback button. You will not see the instructor cheat button. And then you got the more instruction button, which I would recommend using if you're ever struggling with problems or objectives, and click on this and some reading material or videos will pop up, and hopefully those things help you out when working on that particular problem. Alright, so the first question is on the objective, determine if an ordered pair is a solution of a system of linear equations. So we're going to be looking at, in this section, we're going to be looking at systems of linear equations with two variables, right? So just x and y are, and most of these I think will be just x and y, right? And what we're trying to do is determine what ordered pairs are solutions of the system. Alright, so I'm going to write this out, and then we're going to test, every single one of these to see, until we get a solution, right? It says select the correct answer below, so only one of these should work. Right. Okay, so this is the system of equations we're given. And hopefully you recall, and again, I'm assuming when I do these assignment videos that you've seen other videos of mine or did the reading. Remember that a solution of a system is any ordered pair that satisfies all the equations. Right? So I'll write that out. Right. A solution of a system satisfies every equation. Satisfies. I can't spell, sorry. Satisfies. That says satisfies. A solution of a system satisfies every equation in the system, not just one or the other. Right. So we're checking the following. Right. The options we were given was, the first one was the ordered pair, -4, -1. And remember how these ordered pairs, we're talking about points on the coordinate plane, xy coordinate plane. The first coordinate was a value of x, and the second coordinate in the ordered pair was the value of y. So I go through each equation here and see, does this value of x and this value of y make both equations true? Alright, well, let's see. First equation. So I'll write this. I'll do first equation. Second equation. Make a little column here. Right. So when x is -4, y is 1. First equation. We have the opposite of x, which is -4, plus y, so plus, negative 1, is that equal to 3? Well, this would be positive 4 plus negative 1. That is indeed 3, and we have 3 equals 3. This is true. Great. Now, that means that this ordered pair, right, this is a solution of the first equation. That doesn't mean that it's a solution of the system, right? It has to also be a solution of the second equation. So the second equation, y, or negative 1, equals x, negative 4, divided by 2, minus 1. So the left side's negative 1. The right side would be negative 2 minus 1 would be negative 3. We have negative 1 equals negative 3. That is a false statement. So a big X there. So that means that this ordered pair, right, negative 4, negative 1, is not a solution of the system, right? It's a solution of the first equation, but not of both equations. So not a solution of the whole system. Okay, hopefully I understand the difference. Okay, the next one. And again, we're just going to keep going until we find the, it says select the correct answer below, so only one of these should be working. The next ordered pair we're given is 3 for x and 1/2 for y. Alright, so in the first equation, we have negative 1 times x, so negative 1 times 3, plus, and then 1/2 for the y, and then you have equals 3. Alright, go to the first equation again. The negative 3 plus 1/2, that's negative 6 halves plus 1/2, that's negative 5 halves, right? Negative 2.5 on the left and 3 on the right. This is definitely false. And so, you don't need to even check the second equation, right? If it doesn't satisfy the first equation, it's definitely not going to be a solution of the system. All right, the third ordered pair we're given is 5/7 for x, 1/5 for y. Alright, so the first equation, negative x, negative 5/7 plus y plus 1/5, is this equal to 3? And I'm hoping it's obvious that it's not. But if I get a common denominator, I'd multiply this fraction by 5 over 5 and this fraction by 7 over 7. You'd have negative 25 35ths plus 7 35ths, negative 25 plus 7 would be negative 18. Negative 18 35ths on the left and 3 on the right, clearly false. Alright, so once again we have an ordered pair that's not a solution. Alright, so the next ordered pair we are given is the ordered pair negative 8 for x, comma, negative 5 for y. First equation, we have negative 1 times x, so negative 1 times negative 8, plus negative 5 equals 3. Well, this would be positive 8 plus negative 5, that is 3. 3 equals 3. That's true. Okay, so far so good. So it's a solution of the first equation, but is it also a solution of the second equation? So I replace y with negative 5. So I have negative 5 on the left equals x divided by 2, negative 8 divided by 2, and then minus 1. So I have negative 5 on the left, and on the right side, negative 8 divided by 2 is negative 4. Negative 4 minus 1 is negative 5. Great, negative 5 equals negative 5. That's also true. So here we go. All right, this is it. This is a solution of the system. It satisfies all the equations in the system. Great. And so I go back, and that's the one I'm going to toggle. The ordered pair negative 8, negative 5. And if you were to check ordered pair 3/5, it wouldn't work. Because look, right away, the first equation, you'd have negative 3 plus 5 equals 3. That's not true. So that's the only one that works, negative 8, negative 5. Right, and remember, after every problem, after every question, you are going to get an answer explanation. Please read through this, whether you got it right or wrong. If you got it right, and you were, unsure as to why you got it right, maybe read through this and see, hey, did I get lucky, or did I actually, write out the correct stuff? Did I know what I was doing? If you got it wrong, read through the answer explanation and try to figure out why you got it wrong, right? What went wrong? So that way, the next time you see a question from that objective, hopefully you'll fare better. Okay. So moving along, next question. Okay. Same objective. Determine if an ordered pair is a solution of a system of linear equations. So I'm going to do the same thing on a piece of paper. I'll write the system, and then we'll start scrolling through and checking these ordered pairs that were given. And again, notice it says select the correct answer below, so only one of these should work. Okay, so I've written out the system. And once again, I'll make a little column here. We got first equation, second equation. There's only two of them. Now the first ordered pair we're given to check is the ordered pair 4, 0. And once again, the first value is going to replace x everywhere. The second value is going to replace y. And in order to be a solution of the system, right, all the equations, both equations, have to be satisfied. Right, so in the first equation, we have negative 1 times x, so negative 1 times 4, negative 4, plus 4 times y, right, 4 times 0 equals negative 3. The left side would just be negative 4 plus 0, so negative 4 equals negative 3 is what I end up with. That is false, and so this 4, 0 is not a solution. I'm getting rid of it. Alright, the next ordered pair we're given is negative 9 for x and negative 3 for y. Alright, so we have negative 1 times x, so negative 1 times negative 9, plus 4 times y, 4 times negative 3. Is this equal to negative 3? Well, this would be 9 plus negative 12, which would be negative 3. We have negative 3 equals negative 3. That's true. Great. So this is a solution of just the first equation. Now, let's see if it's a solution of the second equation also. So y on the left side says negative 3 on the left equals 2 times x, 2 times negative 9 divided by 3, and then plus 3. I have negative 3 on the left, and then numerator is negative 18 divided by 3 would be negative 6, and negative 6 plus 3 is negative 3. Fantastic. This is true, so here it is, the solution of our system, of all the ordered pairs that were given to us. Right. Now the system might have more than this solution, but again, of the ordered pairs that were given to us, this is the only one that works. Right. And you can check the other ones if you want, but again, because they have the word "the" correct answer here, that should be the only one. Great. All right, same thing. Next example, I believe, will be on the same objective, and it is. Right, so once again, we're given a system of equations involving x and y, two variables, two equations, and we're trying to determine which of these ordered pairs would satisfy the system. So once again, I'm going to write this out. Okay, so here's the system. And I'm going to do two columns again, first equation, second equation, where the first equation is the top equation, the second equation is the bottom equation. And the first ordered pair we are given is negative 1, 4. And don't forget, negative 1 replaces the x. The second value, 4, replaces the y's. So in the first equation, we have negative 5 times x. So negative 5 times, negative 1, minus y, so minus 4. And is this equal to 2? Well, the left side would just be 5 minus 4, which is 1. 1 equals 2 is false. So this ordered pair, negative 1, 4, I'm going to get rid of that. That's not a solution of this system. The next ordered pair we're given to check is the ordered pair 5, comma, negative 23. Right? So 5 for x, negative 23 for y. First equation, we have negative 5 times x, negative 5 times 5, minus y, minus negative 23, which will become plus 23. And is that equal to 2? This is negative 25 plus 23, that'd be negative 2 on the left, positive 2 on the right, so this is false. Those are not the same number. So this ordered pair is not a solution of the system, doesn't satisfy both equations. The next ordered pair I'm given is 1 for x, 3/7 for y. So first equation, we have negative 5 times x, so negative 5 times 1, minus y is 3/7 equals 2. I'm hoping you see this is false right away, because this is a negative number on the left, a positive number on the right. So I'm not even going to bother adding those together. This is going to be false. So it can't be a solution of the system because it doesn't satisfy the first equation. It's got to satisfy both. Next ordered pair we're given is 1 for x, negative 7 for y. So the first equation, negative 5 times 1 minus negative 7 equals 2. This would be negative 5 plus 7. That is 2. Great. So far so good. This ordered pair is a solution of the first equation, but again, in order to be a solution of the system, it has to be a solution to all the equations. So second equation, we have negative 4 times x, so negative 4 times 1, minus y, so minus negative 7. And is that equal to 3? Well, we have negative 4 plus 7. Negative 4 plus 7 would be 3, so 3 equals 3. Let's put a check mark. That is true. So this ordered pair is the solution we're looking for out of those ordered pairs that were given to us. This does satisfy both equations at the same time. So I'm clicking on that. Great. Alright, next one. And I believe this will be the last one involving this objective. Alright, so once again, determine if an ordered pair is a solution of a system of linear equations. We're given a system. We're given a bunch of ordered pairs to test. And see if these, which of these satisfy both. Right, so once again, I'm going to write it out, do some columns, and we'll start going through them. All right, so here's the system that's given to us in this equation. And I got the columns here, and we'll start checking these ordered pairs. Now the first ordered pair we're given is 7/2 for the x coordinate, right? And negative 3/7 for the y coordinate. Alright, so putting those into the first equation gives me 7/2 plus negative 3/7. And is that equal to 3? Well, I'm hoping it's obvious that this is not true. Alright, if I got a common denominator, This would be 49/14 plus -6/14 would be 43/14, which is not equal to 3. It's very close, right? 42/14 would be equal to 3, but not 43/14, right? So this is false, meaning that this ordered pair is no good. I'm going to cross it out. Right? The next ordered pair we're given is -5 for the x, -2 for the y. So first equation, x, which is -5, plus y is -2. Is this equal to +3? No, the left side would be -7. So again, this is bad, right? I put an x next to that, a big cross out. This does not satisfy the first equation, so it can't be a solution of the system. All right, how about the next ordered pair we're given is 3 for x, 0 for y. Well, first equation, x plus y, 3 plus 0, is that equal to 3? Absolutely. We get 3 equals 3. Hooray, I'll put a check mark for yes. So now that we have a solution of the first equation, right, in order to be a solution of the system, it has to satisfy all the equations. So I check the second one as well. So -3 times x, right, -3 times 3, minus 2 times y, so -2 times 0, is this equal to -9? And yes, it is. This would be -9 minus 0, which is -9. And you have -9 equals -9. Check on that. Both equations are satisfied by this ordered pair 3, 0. So this is a solution of this system. And that's the one I will toggle. Alright, and that's it. And then again, you can try checking the other ones, but they will not work. Hooray. Alright, so confetti coming down, right? You completed one of the 2 objectives. Fantastic. Now the other objective is on actually solving the system yourself. Instead of checking a bunch of ordered pairs that were given to us, we're going to find the ordered pairs that satisfy a system ourselves. And then we'll enter those values in the answer choices in the answer area here. Alright, so I'm going to talk about this elimination method that they're talking about using once I write this out and take you to a piece of paper. Alright, so here's the system we're getting. And we're asked to find a value of x and a value of y that satisfy both equations, not just one of them. Alright, now this elimination method, I'll write out the steps I'm following out here. Right, elimination method. So the first step is I get each equation in the form a times x plus b times y equals c. So basically, I just take all the variable terms to the left side and constant terms to the right side of the equal signs. And be sure to line up like terms, right? So you see how the x's are lined up, the y's are lined up, okay? And then the constants are lined up on the other side. The second step, I'm going to choose a variable to eliminate. Now, with experience, with practice, it'll be easy to see which variable will be easier to eliminate than the other. So here I'm going to eliminate y's. Right. So I'm choosing to eliminate y. And here's how that's done. Third is Find the least common multiple of the coefficients of this variable. And I'll say ignoring negative signs, right? So what's the least common multiple, sometimes referred to as LCM, of 4 and 12? That would be 12, right? That's the smallest number that both of these go into evenly, the least common multiple. Right, then we're going to multiply the equations by some numbers to get the coefficients of our variable, right? The variable we want to eliminate, to get the coefficients of that variable to be opposites. So I'm going to multiply the equations by some numbers, not necessarily the same numbers. To get opposite coefficients. On the variable. So when I talk about the least common multiple of 4 and 12 being 12, I want, we want positive 12 and negative 12 to be the coefficients of y, right, if I'm trying to eliminate y. All right, well look, negative 12 is already a coefficient of one of the y's, so I don't need that one. I already got it. So the other coefficient I want to turn into positive 12. And in order to do that, I would need to multiply by 3. Now you don't just multiply this by 3, you multiply both sides by 3. So I'm going to say multiply by 3, and you're doing it to every single term, right, on both sides, just like any other equation. So after doing that, we get in what's called an equivalent system. The first equation, I multiply everything by 3. So we'd have 5 times 3 is 15. 15x plus 12y. Right, and there's the positive 12. Right, so I can cross that off. I'm not going to write these in future examples, right? Just know that we want the coefficients of the variable we want to eliminate to be opposites. One, positive and negative of the same number. Equals, and then the other side, negative 20 times 3 is negative 60. Then the second equation, since the coefficient on the y was already one of these 12s, it was negative 12, I don't have to do anything. I'm just going to leave it the way it is. So negative 7x minus 12y equals negative 4. Alright, now that the coefficients of y are opposites, positive 12, negative 12, we get our fifth step. Add the equations to form a new equation. So let's just add the sides. And the equal signs all line up. And you combine like terms on the left side and right side, adding. This will, if the coefficients of one of the variables are opposites and you add them, they're going to have 0, right? 0y. That's why this is called, elimination. This eliminates y. And then I have 15x plus negative 7x, that'd be positive 8x. And then 0y, 12 plus negative 12, equals, and then negative 60 plus negative 4 would be negative 64. And look what happens. After you eliminate one of the variables, you're left with an equation. Right? You're left with an equation that has just one of the variables and not two. So then you solve this equation. Solve this resulting equation. Now that would just, you have 8x equals negative 64. You would just simply divide by 8 and get x equals, negative 64 divided by 8 would be negative 8. Now this here, this is just the x value of the solution. This is not the entire solution. Remember, there are two variables, x and y. We have just found the x value of the solution. All right. And then the last step is go back to any equation with x and y in it. So the first equation, the second equation, right? Go back to any equation with x and y in it, replace x with negative 8, and solve for y. So back to the first, so we go back to any equation with x and y. So say the first one, 5x plus 4y was equal to negative 20 in the first equation. And I substitute, x equals negative 8. I am substituting this for x in this equation. So now this becomes 5 times, negative 8 plus 4y equals negative 20. And then we solve for y. So this would be negative 40 plus 4y equals negative 20. I would then add 40 to give me 4y equals, negative 20 plus 40 is 20. Divide by 4, y equals 5. And then here is the y value of the solution. Right, so then we can put these together and state the solution of this system. Right. So the solution of the system is the ordered pair. Now be careful that you're putting these in the correct order. Remember, it's the x first, negative 8, comma, and then the y value second, right? Negative 8, comma, 5. And then this is what we're going to enter. Now, of course, also check your solutions, right? Don't forget to check. Go back to the original system, and I'm just going to do this mentally, right, out loud. Replace x with negative 8 and y with positive 5. You'd have negative 40 plus 20 equals negative 20. That's true. The first equation is satisfied. And then again, same thing for the second equation. You'd have positive 56 minus 60. 56 minus 60 would be negative 4. This does satisfy both equations, so it is indeed a solution of the system. Don't forget to check your solutions. And if it doesn't work, then you did something wrong somewhere, and go back through your work and try to figure out what happened. All right, so back here, entering, now they already got the parentheses, right? So I don't need to enter the parentheses. I just need to enter the first coordinate. The x coordinate was negative 8. Then they already have the comma there as well, so no need to put the comma. And then the y coordinate was 5, right? I'm just filling in those blanks of the x value and the y value. Submit. Again, please read through the answer explanations. Okay. All right, and then this is what we're doing for these. I think I'm going to be doing 4 of these, right? It's usually 4 questions per objective. Unless you get things wrong, right? Then they ask you more questions. So here again, I'm going to write out this system, and we'll go about solving it by the elimination method. So we have negative x plus 3y equals negative 2, and 2x plus 5y equals negative 18. Right. So here we go. Alright, so again, choose a variable to eliminate. Again, it doesn't matter which one you pick. I am going to eliminate x's this time. Again, you'll see eventually it really doesn't matter, but you'll eventually get to the point where after enough practice you'll see it'll be probably easier to eliminate this variable than that one. Alright, so then I find the least common multiple of the coefficients of x. Now they're negative 1 and 2, but just ignore the negatives. The least common multiple of 1 and 2 is 2. So that means I want a 2x and a negative 2x, right, in these equations. Well, the second equation already has 2x, so I don't need that. I want the first equation to have negative 2x then. So that means I need to multiply, or I'll write times, multiply both sides. To change that to negative 2, I would have to multiply by positive 2. So I'm going to multiply everything in the first equation, both sides, every term, by positive 2. All right, and that'll create this equivalent system. First equation, multiply everything by 2, we'd have negative 2x, and there's the negative 2x I wanted. So now I have both. I have positive 2x and negative 2x in this system. Plus 6y, right? 3y times 2 equals, and then negative 2 times 2, negative 4, right? Multiplying every term on both sides by 2. The second equation, you could say times 1 if you want, but I'm not changing it because it already has the positive 2x that I want. And then plus 5y equals negative 18. Alright, now that the coefficients of x are opposites, right, positive 2, negative 2, I will add these equations together, getting a new equation. Again, equal signs line up. You're just combining the like terms on the left, combining the terms on the right. The x's are gone. 6y plus 5y is 11y. Negative 4 plus negative 18 is negative 22. Then I can solve this equation for y. Right? Dividing by 11 gives me y equals negative 2. So I'll squiggly underline this. There's the y coordinate of the solution. And then I go back to any equation, right? Any equation with x and y in it. Substitute negative 2 for y and solve for x. So let's go back to the first equation. We have negative x plus 3 times y equals negative 2. And I am replacing y with negative 2 and solving for x. So we have negative x, plus 3 times negative 2 equals negative 2. That's negative x, minus 6 equals negative 2. Then adding 6, I got negative x equals 4. And then dividing by negative 1, x equals negative 4. All right, so the solution of this system is this ordered pair, right? X is replaced with negative 4, comma, y would be replaced with negative 2. And that's what we're going to enter. So again, just filling in the blanks, no need to type the parentheses or the commas, right? Negative 4 for the x, move it over, negative 2 for the y, and submit. And again, please read the answer explanations. Alright, next system. Same thing. And notice that almost all these examples are set up the way I wanted to start them having be set up, where all the x's and y's are on one side and the constants on the other, and the x's are lined up, y's are lined up. So they're already like that. There might be other systems where you'll have to do that yourself, just move some terms, add and subtract some terms to get all the variables on one side lined up and all the constants on the other. But for the most part, we'll see that every system here in this assignment are already set up nicely for us. Alright, so same thing here. Now it would be easier to eliminate x here. Just multiply the second equation by negative 2. But I'm going to eliminate y. All right, again, I know it would be easier to eliminate x because I don't have to multiply the second equation by negative 2, but let me show you what, you can multiply both equations by some number. So let's say I decide to eliminate y this time, right? Again, it doesn't matter which one you choose. Now the least common multiple of 3 and 5 is 15. All right, that's the smallest number that both 3 and 5 go into. So that means I want 15y and negative 15y to show up in these equations. So the first equation has negative 3y. Now I could turn that into negative 15y by multiplying by 5. Right? So the first equation, I'm going to write, times 5. I'm going to multiply everything on both sides by 5. That'll give me the negative 15y. Second equation has 5y, positive 5y. Now I already did the negative 15y, so I want to change this into positive 15y, and that would just simply be by multiplying by 3, right? So times 3, second equation, both sides, every term. Alright, so that'll create the following equivalent system. The first equation, I'm multiplying everything by 5, so that'd be 20x minus 15y equals 15. The second equation, I'm multiplying both sides by 3. Pardon me. So 6x plus 15y equals negative 93. Alright, now that the coefficients of y here are opposites, right? One's positive 15, one's negative 15, adding the equations together will eliminate y. So I add the sides. You can line up the equal sign here, combine the sides on the left, the terms on the left, combine the terms on the right. So I'd have 26x, 26x. The y's would disappear. Right? It'd be 0y. And then on the other side, see, 15 minus 93 would be just the opposite of, that'd be 78, right? Negative 78. Because, 78 plus 15 would be 93. Okay. And then divide, now I'm solving for x. Right? Very simply, divide by 26. X would be equal to negative 3. Right? 3 times 26 is 78. 60 plus 18. So here's the x coordinate of the solution, negative 3. And then I go back to, again, any equation that you see with x and y. This one, this one, this one, this one. Any equation with both x and y in it. And I replace x with negative 3. And then solve for y. So I'm going to go back to the first equation and go, we have 4 times x. Right, 4 times x. But x is, I'm going to replace with negative 3. Then minus 3y equals 3. And now I'm solving this for y. So that's negative 12 minus 3y equals 3. I would add 12 to get negative 3y equals 15, and then divide by negative 3 to get y equals negative 5. So the solution here is negative 3 for x, comma, negative 5 for y. Right? That ordered pair is a solution. And don't forget to check, right? I didn't do it the last one, but don't forget to check your solutions. Right? Make sure this is actually a solution of the system. Replace x with negative 3, y with negative 5, and see that both equations are made true. And I'll do that really quickly out loud. If x were negative 3 and y were negative 5, this would be negative 12 plus 15 is 3. That's true. And the second equation would be negative 6 minus 25, right, would be negative 31. That's also true. This is indeed a solution of the system. And that's what I'll enter. Now again, they already got the parentheses here, the comma. You just need to enter the x coordinate, negative 3, and the y value, the y coordinate, negative 5 of the solution. And submit. Alright, I believe I'll have one more of these. Okay, so once again, I'm going to write this out on some paper and come back. We'll solve using this elimination method. So here's the system. Just because the coefficients of x are smaller, that's what I'm going to choose to eliminate. So I'm going to choose to eliminate, all the x's and y's are lined up on one side, constants on the other. And I'm going to choose to eliminate x. So then I'm going to find the least common multiple, LCM, of the coefficients of x, which are 2 and 3. So that'd be 6, right? So I want to have 6x in one equation and negative 6x in the other one. All right, I want opposites. So for the first equation, I got 2x. I could multiply that by 3 and get the positive 6x. Right, so times 3. Multiply everything on both sides by 3 in the first equation. Now that'll give me the positive 6x. So I would like to change the other x term into negative 6x. Well, it's positive 3x. To change it into negative 6x, I'd have to multiply the second equation, every single term on both sides, by negative 2. That'll give me the negative 6x. Great, so let's do that. Write the equivalent system. All right, first equation, right, I'm multiplying everything by 3. So that'd be 6x plus 27y, right, 9 times 3, equals, and then negative 4 times 3 is negative 12. Second equation, I'm multiplying every term on both sides by negative 2. So that gives me the negative 6x minus 26y, right, 13 times negative 2, equals, and then negative 2 times negative 7 would be positive 14. So you see now the coefficients of the x's are opposites. I'll now add, if I add the equations now, the x's will be eliminated. Line up the equal signs, combine the terms on the left, combine the terms on the right. X's are gone. 27y plus negative 26y would just be 1y. And then negative 12 plus 14 is 2. And that's it right there. There's your y value. Nothing to do after that. Y equals 2. Now that I have the y value of the solution, now I just go back to any equation with both x and y and solve for x after substituting 2 for y. So let's go back to this first equation. Here we have 2x plus 9 times y, but I'm going to replace y with 2. 9 times 2 equals negative 4, and then solve this for x. Right? This would be 2x plus 18 equals negative 4. Subtract the 18, we'd have 2x equals negative 4 minus 18 would be negative 22, and then dividing by 2, x would be negative 11. So the solution would be negative 11 for x, comma, 2 for y. Right? That's the ordered pair we're going to be entering. And double check it. Right? If you were to replace x with negative 11 and y with 2, would both the original equations be true? Would every equation in the system be true? Let's see, we'd have negative 22 plus 18, that would be negative 4. Great, so the first equation is satisfied. Then the second equation, we'd have negative 33 plus 26 would be negative 7. So this is indeed the solution of this system. So back here, just entering the x and y coordinates of the solution, negative 11 for the x, 2 for the y. And again, be careful, make sure you're putting the x value first, the y value second, right? No matter what order you found them in, right? The x has to go first, y has to go second. All right, great. And again, read the answer explanations. They should help you, especially if you got something wrong. You can probably figure out where you went wrong, I'm hoping. And that should be it for this assignment. All right. Now again, that's it for this version of the assignment, right? The version of the assignment you saw me do just now, the questions you saw me do, aren't going to be exactly the same questions. I mean, some of them might be the same, but not all of them will be the same as the ones you're going to see when you work on the assignment yourself. But the objectives are the same. The types of questions you'll see are the same. The way you would do them would be the same. So I'm hoping that watching me go over these examples here in this assignment help you when you're working on the assignment on your own. And thank you very much for watching.